All right, everyone. My name is Ryan Schul. Welcome to my channel. So in the topic today, I want to talk about how we can analyze YouTube comments, and we're going to use Python to do all the work, and everything is going to be in a Jupyter notebook, just like basically all of my other videos, right? Pretty much everything, 100%. So why do we even want to try to understand and analyze YouTube comments? There's a variety of reasons. Better understanding of audience sentiment. Sentiment is feeling, right? How do you feel? And the goal could be to find out how many people feel positive, neutral, or negative about a video, about a product, a certain topic. The list goes on and on, right? To discover trends, topics, opinions of people, to identify common themes or trends. Maybe people have a lot of questions, or there are other various interests. We can do this to detect toxic or inappropriate comments. You see this on YouTube occasionally, hopefully not too often. Fortunately, not too often, but it happens, right? And the goal would be to automatically flag bullying and hate speech or spam and just remove that, just delete that automatically, right? We can analyze engagement and popularity. So how popular are certain videos? Highly popular, mediocre, not popular at all, right? But we can better understand the comments. Based on the comments, we can understand trends, likes, dislikes, replies, how people engage with the videos, right? Audience profiling and personalization. That's a big one too. The goal would be to learn more about your audience's demographics, writing styles, behavior, so on and so forth. And then academic, cultural, or psychological or sociological research, right? That would be a little bit more academic focused, right? But we could study digital behavior, information, misinformation, public opinion shifts and trends over time. So I'm going to go ahead and fetch YouTube comments from this video. Let me show you what I did over here. So go to YouTube, YouTube, and YouTube's coming up. Okay, let's look at one video and just pick one random thing here. Okay, bear with glasses. Okay, something very realistic. Probably see this all the time. Every time you leave the house, right? You see a bear with glasses walking around. Let me click on that. And we can see, if we look closely at this thing right here, before the ampersand, we have the unique identifier of the video. So I'm going to go ahead and paste in the ID. The equals sign equals the ID of the video. Hit enter. And we see YouTube, okay, with a little ad popping up. So how did I get that? Basically, I just I set this as YouTube ID, and we need an API key. If I take a step back, right here, www.youtube, and type in YouTube beautiful day. There's a couple ways to get this ID, right? So YouTube, okay, that's one of their more popular songs. So do a search, and here it comes. Okay, and again, you just have to look close. It's not hard at all, but anything after the ampersand, it doesn't really matter for this video. I'm not even sure what that is. Maybe metadata, maybe data related to other similar types of videos. I'm not sure, but this is the ID right here. After the equal sign and before the ampersand. All right, so if I take a step back, before the ampersand and after the equal sign, that is the identifier of the video. So let me just pause that and paste that over here. So now we have the identifier, and the API key basically just comes from here. Do a Google search, GCP API key. So this is Google Cloud Platform. You can hit enter. So if you have your own API key, you can just copy and paste it. If you don't have an API key, you can go ahead and sign up for one. Really easy. Just follow the prompts over here. This is the main page. Go to console. So the console is kind of like the starting place for everything in GCP. This is like the jumping off point. And then you'll see a view that looks pretty much like this. Yours might be slightly different. It might be identical. If it's slightly different, you should still see API services over there. Click on API services, and then you'll see API services. You see that I have some enabled over here. Okay, and you have credentials over here on the left-hand panel. You can have enable API and services. I think this is the one. If not, it's credentials. API services. Let's see, YouTube. Enter YouTube analytics. So I'm not sure. I'll probably pick this one. And then try this API. Okay, so it says try the API. So I guess I don't have that one. Maybe I have the first one. No, I don't have that one. YouTube reporting, it says try or enable. So, I guess there's multiple APIs. I don't have any of those, but that's fine. You can enable any one of those three and it should work totally fine. If you go back here, SAP, you should see, if I go over here, YouTube. Yeah, so here's mine, okay? So YouTube Analytics API, that's mine. If I go over here and click on this, I will have, where is it? Credentials, so I think I have to go over here. Okay, I'll get the cred screen. And that loads up, and here's my API keys. All right, so mine is gonna look something like this. So I'm not gonna do it. I don't know if that actually shows it or not. Let me go into a different screen. Does that actually show the thing? Give me a second here. Oh, it does. Yeah. Okay. So I can't do that. Okay. But sometimes it just shows you a portion of the API key. But anyways, you set it up. It's pretty quick. 60 and 90 seconds, you're done, and you can access your API keys over here with credentials. Okay. So pretty easy. I just showed you how to do that. I'm going to turn off. I'll leave this like here. I'll leave this right here. This is an advertisement. Okay. I didn't recognize that for a second. That's an ad. Let me turn this off too. So I don't need that. So let me pause it here too. So we have the identifier right here. Every video has its own unique identifier. We have that, and we have the API key. That's all you need to get started here. Now, I put together some comments as a list, likes, authors, author IDs, and timestamp. So I want to go through and fetch all of that from the YouTube API. So I'm going to get the snippet, comments, likes, authors, author ID, and timestamp when the API came out. And then I'm going to take all of those, append those to that list, right? Anything with a square bracket is a list. I'm going to do .append, so timestamp.append, and then take all of that and convert that into a data frame. So when I run that, I will have this final product with 21,501 rows and 5 columns. So here's the 5 columns: author, channel ID, timestamp, comment, and like. Those are the 5 columns. And I have 21,501. When I first got this, I thought, okay, this is not too bad. I looked at the YouTube API documentation, pretty straightforward, right? But then I noticed I had 21,501 records, and it's actually 27,460 comments. So it took me a moment to figure out what was going on, and I realized what this does is get the top level comments, all the original comments. But if there's comments of comments or sub comments or something like that, it skips all of those, right? So these are all straight up comments. Okay, these are all comments. Comments. Right, so for the most part, you'll get comments, but sometimes you'll get comments of comments. Okay, so here's an example: replies. So you have 3 replies to this comment right here. Here you have 39 replies to this comment, right? So if you just scan through all the records this way, you'll get all the original comments, right? But if you want responses to comments, you have to go another level deeper. Again, use your API key, same video ID, and we're going to create a function to get replies data. So again, these are all the comments over here at this level, at the high level. That would be a comment. These 39 replies right here are a sub level. So these are kind of like the children comments of this parent comment. So that's how it works. Okay. So if you want to get the replies data, these are basically kids of the parents. The comments are the parents, and the replies are the kids. So just like before, we have the author, the channel ID, timestamp, comments. Like, is reply. So is this a reply or is this a comment? Comment is of high level, the first level. A reply is somebody responding to a comment, okay? And then you'll get the parent ID. So just like before, we get these different levels of data points. This is basically considered metadata. Well, kind of, I don't know if that's meets the exact definition of metadata, but close enough. So we pull the top level comments, we pull the replies to the comments, and convert everything to a nice tightly coupled data frame. That's what we do down here. So again, we have the author channel, timestamp, comment, like, reply, parent ID. Everything goes into a data frame. These are all the comments data. If I do Control F, this comments data is basically a dictionary with key value pairs. This is the key. Anything on the left of the colon is key, and these are the values over here, okay? So the values describe what is in the key. You can think of this like a telephone book. So the phone number would be the key, and then the value would be the person's name, address, zip code, things like that, right? So you always have like a key and a value, and these are all paired together. So we take all of those dictionaries and convert that into a data frame, and then we come up with this: author, channel ID, timestamp, comments, likes, is, reply, and then parent ID, right? So before we had 5, 1, 2, 3, 4, 5 over here. So in this script right here, we have 2 more headers over here: is, reply, or parent ID. And when I run that, I get a total of 27457. And if I go back here, should see exactly the same thing. 27460. Okay, I ran this yesterday, so there's 3 more comments. I'm not going to rerun it because I can't share my API key, right? If I record this video and run the key, you guys can see my key. I can't do that because then they'll have access to all my Google GCP data. So I can't do that. I'm not going to rerun it, but you can see, like, conceptually, it's pretty sound here. 27457, 27460. So 3 more comments were posted in the last 24 hours or whatever. I wrote the script yesterday and demoing it today. So that's the whole thing. So if you want to get all the comments and use the first script, if you want all the replies and the comments, use the second script. Okay, so you can see again, you get 21501, right, with no responses to comments. It's just the comments. 27457 gets all the comments and all the responses. So we did a lot of work there, and I tried to run this script, and it was running really slow, and it was kind of like chunking along and then kind of sucking up a lot of memory and took a lot of time. I eventually gave up and said, let me take a random sample, okay, a random sample of the data frame. So the data frame has, remember, 27457 records. So not that big really, but for Python, when you start to apply some of the processes that you'll see in a minute, it's very time consuming and very labor intensive. So if you don't have a machine with a lot of RAM, or if you're not running this on the server farm with a lot of clusters of servers underneath, then all I can say is good luck, because the NLP tasks that we're going to be doing in just a minute are really takes a lot of compute power, and my laptop just isn't going to, it's not going to handle it. I have a T14 solid state drive, so kind of fast, but it just can't do all these big data things, right? It's just too much. So I'm taking a random sample and a fraction of the original, what was it? 27457. I'm taking the sample of that, so I get 6864. So you'll see in some of my other videos, if you're dealing with big data sets, this is not by any means big, but for my machine, what I'm trying to do is actually pretty big. I'm a big fan of just getting something done, getting out the door, doing a POC, which is proof of concept, or MVP, which is minimum viable product, and just getting something to work. Okay, so if I go to my stakeholder and say, this is what I did in the last 24 hours, let me show you, let me take you through it, let's do a sit down and discuss this. They will be thrilled. They'll say, okay, show me what you've got. If you go back to the stakeholder and say, well, the computer ran out of memory and I couldn't do anything, okay? They're going to be like, well, what the heck? Like, make it work, right? Go back to your desk and figure it out and make it work. I want to see something. Something's better than nothing. We only have 1/4 of the records, but it's fine. We can move on. We have something to work with here, okay? So if you put this on Databricks or a computer with big horsepower or lots of gigs of RAM, it's going to work. On my machine, it just doesn't work. So anyways, I'm going to do a quick text blob analysis to get the polarity and the sentiment of the records here. So I'm not going to rerun it, okay, because I don't have the API key hooked in there. And obviously I can't expose that for obvious reasons, right? That's personal and confidential. But everything is here, right? And I saved everything so you can see what the script does. I'm just not going to run it in real time. So let me go over here. I should have put this in my notes the other day, but I didn't do it. Thought about it, but I didn't actually do it. Difference between and what was that? Sentiment. Okay, I don't like these sponsored things. So sentiment analysis. This is probably good enough. With clarity, why is it not enough? I just want a nice condensed, abridged definition here. Okay, I'm busy. Busy. So, I'll go back and fill that out. Note to myself. Difference. Basically, polarity is how diverse, not diverse, but like how extreme, I guess, how extreme the text is, and sentiment is the feeling. Is it positive, neutral, or negative? Okay, so I'll come back and I will fill that in. I'll make some notes after the video. I don't want to take a lot of time to do that, but you can see the neutral, the number of comments that kind of have like a neutral tone to them: 3,323, positive 3,017, and negative 524. So I don't think YouTube is a negative band by any means of the imagination. A lot of people love it. Maybe some people are neutral. To see 524 negative comments is kind of shocking. I wouldn't expect that. Maybe people were in a bad mood when they posted the comment. I don't know. So here's a word cloud. We can go ahead and get the comment section again. Remember, we're looking at comments over here, and all the comments comes from this field right here. So we have the original data, we have comments, polarity, and sentiment, and now we have now we're creating a word cloud. So word clouds basically just take all the text, and based on the frequency of certain words showing up. So beautiful day comes over and over. You too, song, Bono, good, love. Now this isn't the lyrics of the song. This is the comments underneath the comments section. Okay. So these are all these comments over here, and over here, right? So again, here's the positive, neutral, negative tone of the comment, and here is a view of the frequency of the words that show up in the comment. So the bigger the word, song, you too, love, Bono, good, beautiful day, the bigger the word and the more space it takes up, the more frequently it shows up in that comment field. Okay, so let's move on now and look at let's see, comments as comments based on, trying to think, now why did I do this twice? So it's a similar concept. I don't know why it's twice. Word cloud, so I'm using word cloud here, word cloud here, word cloud to word cloud, image buffer, save, PNG, saving the image. Oh, I see. Okay, the only difference between these two is this is, I'll probably just delete this. This is a little bit more simplistic. That was a matplotlib plot, and this is a plotly plot. Okay, I like these plotly plots because they're dynamic, they're interactive. You can zoom in, you can zoom out, things like this, right? And I think this one is, yeah, it's kind of a different kind of plot. I guess the word clouds don't let you zoom in, but with all these plotly plots, for the most case, with the exception of word clouds, I guess, I just found out now, you can zoom in and zoom out and scan over the plot, and you'll have bubble messages popping up. So they're very interactive and very, very simple and easy to work with. So let's look at another concept here. Now this takes a while to run, but we basically get advanced sentiment and emotional analysis, and we're using a transformer. So a transformer is the backbone behind an LLM. So this is a large language model, and we can get much more rich meaning and feeling and purpose from this text. In the original version I showed you over here, this is very simple, very straightforward. It's called a text blob. So it's giving you polarity and sentiment. And down here, you actually have a mini LLM, large language model, and we're using, what is this? Text classification. This is the type of LLM, and we're using this type of model right here. We have a tokenizer. It has a maximum length of 512 characters. Anything less than 512, we have to reduce that down to a more bite-sized, manageable length for the model to consume it. So that's what these lines down here are doing. We're applying lambda anything greater than 1,000. We truncate that to the first 1,000 characters. So if somebody goes on and on and on and on and on with the comments, we don't have to know every single nuance and every detail of that. We're going to capture the first 1,000 characters, and that will essentially approximate the mood and the feeling and the sentiment and the polarity of that comment, right? Of that person's comment. So this is what we end up with. The first one is very simple, very primitive. Now this LLM using a transformer gets more interesting and a little bit more complex. So we have the author ID, timestamp, comments like is reply. So we have the parent ID, and then we have the polarity of sentiment. We got that before. Okay, and here's the scores. Sentiment, again, positive, negative, neutral. Polarity goes from -1 to +1. The more positive, the higher the number, the more positive the feeling is of the comment. And if it starts to go negative, then that's kind of like a negative tone. So you can see negative, negative here. This is neutral, neutral. So these match up, and this is positive. So it's kind of like a numerical representation of sentiment. Okay, you can see the neutral, neutral, negative, negative. So now we have truncated comments. Are you effing kidding me? That is exactly, it's not just the music, mate. It's everything. Grandpa, no, Campania Grande. I'm not sure what that is. Different language, I guess. I don't think it's English. How does this have dislikes? Okay, and that's kind of a neutral comment. 14 was trying to listen to trap and only just started. So you can see in the first text blob experiment that we did, we got very rudimentary, very primitive types of feedback here. Now using an LLM and a transformer to do the work for us, you get much more rich feeling, engaging type of interaction with these comments, right? And then the motion is surprise, neutral, neutral, surprise, surprise, anchor, okay? So we get first truncated comment. This is the first 1,000 characters or less. And then the emotion comes from the truncated comment. So you can see the flow comment comes from here, right? This is the original data frame, flows down here to get polarity. And from polarity, we can get sentiment. Then again, we use comment over here to get the word cloud. And then again, we use comment to create a truncated comment. And from the truncated comment right here, we create the emotion. So hopefully you can see the flow, how everything cascades down. And you can see the logic moving from step to step to step. So the column is the description, comment is the original text, polarity, sentiment from -1 to 1. I'll just use that. That's a good definition right there. Polarity. Then I'll have to come back and do it later. So polarity. Oops. Okay, that looks fine. And then I think I saw a definition down here for that. Sentiment is interpreted. Sentiment. Okay, so we got our definition. Sweet. I don't have to go back and look that up after I wrap up here. And I'll put a comment there, and I'll truncate this a little bit. Okay, boom, done. Nice. Okay, so let me save it, and we will move on. So we have our transformer doing a big lift here and getting more richness from these comments, right? Basically taking everything and summarizing it almost like cliff notes for us. So now we can go ahead and do a toxicity detection, and we're going to truncate text before we classify the text. So again, we set up our pipeline, text classification. This is the model we're using, urinary toxic BERT. And this was the model that we used last time, J. Harriman Distiller Base. And I don't want to go off on a huge tangent here, but let me see. Happy Face, I think, is the name of the service that gives you all these happy models. So you can Google it, and Hugging Face. Okay, whatever. Happy Face, Hugging Face. I think you get the idea. So if you go over here to models, you have quite a few at this point in time. I'm looking. Oh yeah, okay, that's what I want. So 1,816,336 models. Guys, that's a lot of models, okay? Whatever you're looking for here, text classifier, you can search for it by name, DEXC, or whatever, and you have a whole bunch of models here. You have pages 1 to 10 at least. Okay, 289 models to pick from. I picked one over here. I picked this J. Hartman for this pipeline, right? For this transformer, and for the previous one, it was that was the basic one. This is the first transformer that we used. So J. Hartman model came from Hugging Face, and then this is the second one. Okay, so the model is urinary toxic BERT. So it's not hard to use these things. You just have to think about what you're trying to do. I'm trying to do a toxicity detection. If you go over here and put that in the Hugging Face, and search for it. Okay, I didn't find it. Why did I not find it? Maybe because I'm too low on this level or something. Okay, so that's 289 because I'm already in the models. This is the parent. Okay. So here it comes up with a few, right? So that's what you have to do. Just test different models, plug it in right here. This is the model name between the quotes. Test it, see if you like it. If it works good, go with it. If you don't like it, there's a whole bunch of others to choose from. So now we're taking the comment again, applying lambda and the toxic pipe over here. So if you do Control F, that flows down to here, and you have your truncated comment. So we're taking the first 1,000 characters. That's what this is for. And that becomes a truncated comment. From the truncated comment, you create toxicity. And from that, you apply toxicity to the data frame right here. Okay, so data frame, append a new column called toxicity. And this is a new column. So toxic, 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 toxic. So is this really toxic? I mean, are you effing kidding me? Maybe a little bit toxic. It's not the music, everything. That doesn't sound too toxic, but that's what's being ranked as. So this is not English. Maybe that's why it gets a label of toxic. How does this have dislikes? Maybe it saw the word dislike and it kind of leaned into a toxic report. But that sounds like a little bit weird. But 14 ways of listening to trap that just started. And they said that's toxic. I mean, I find it hard to believe, but that's how the model works. If you don't like it, you can come back here and pick a different one. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, at least 9 there. And then you can try different search terms too. So sometimes the things we see could be counterintuitive, right? The comment could say, play the song all the time, beautiful day, or not. The emotion is joy, and the toxicity is actually toxic. So I think we saw that over here, right? So the emotion was joy. I don't see it here. But this was one record I ran earlier. I did this like 1 or 2 days ago. Why could there be contradictory insights? So this right here could be neutral. This kind of seems contradictory, right? This has neutral and toxic together for the same comment. And all it says over here in the comment is campaign. Well, that one's another language. Let me see if I can find something different. Surprise and toxic. Okay. Those two don't really seem to go together. And the comment was, are you effing kidding me? That's exactly the same thing or whatever. Maybe it doesn't like this. It's kind of quasi curse word, but there could be contradictory insights. There could be model mismatch or oversensitivity. The toxic model may overfit flag terms like play or all the time, or take phrases out of context, and the toxicity classifier are often trained to err on the side of caution. So maybe it's flagging this as toxic just to be safe, even though it's not like real toxic language, right? But there could be different labels and definitions. Sentiment and emotions are judged based on tone and keywords, and toxicity models may look for socially risky patterns, not necessarily emotional tone. So you're amazing, just like a virus that never dies. So you're amazing sounds very positive. I don't think anybody's going to argue that. But then this guy continues, just like a virus that never dies. Like that sounds weird. Why would you put that in the same message as you're amazing? That sounds weird. So that one is going to get flagged as toxic because you're talking about viruses and dying and things like that. It's just weird, guys. It's just weird, right? So you could get contradictions, but you just have to accept it and just move on with it. And again, if you don't like the performance, pick a different model over here. You have 9 to choose from. And if you change your search terms a little bit, probably come up with even more, right? So there's 642 just with one search. So sometimes it's trial and error. You could get different models actually and create a loop over here and say for each item in a list and have like 10 different models in the list and loop through each of the models and then test the performance of each and pick the one that you like the best. So you could do that. Maybe I'll create a video on that. That'll be pretty interesting, but it should be pretty straightforward to create those loops. So again, let's analyze where toxicity, but the sentiment is positive. How can that happen, right? So you have neutral, positive, toxic, joy, positive, toxic. So again, all toxic here. So we might want to take another look at this model, but again, sometimes the computer is making the best guess. It's trying to do what you tell it to do. If you say, show me all the comments here and all the toxic comments, it's trying to make a judgment, right? Just like a person could make a mistake, a computer could make a mistake. computer is much more deterministic than a human, right? So a human would probably make an innocent mistake. The computer could just be programmed to think something different than what should be thought, and a human could actually correct that and say, okay, that sounds like a mistake. But we can count overlaps here, okay? So any kind of toxic positive sentiment, we can look at toxicity equals toxic, right? So this column equals toxic, and sentiment equals positive, okay? So if we have toxic plus positive sentiment, we can count those. And if toxicity equals toxic and emotion equals joy, so like in this record, this emotion is joy, sentiment is positive, and toxic is toxic. We can count those. Toxic plus positive, 3007. Toxic plus joy, emotion, 1962. So there's definitely some overlap. Again, if we pick a different model, we might have slightly different outcome, right? You'd have to massage this and play around with it and basically just test different models and see what the output is. So again, we can look at for toxicity and toxic, and sentiment is negative. So we have all positive sentiments here. We don't have that, but that's only the view. In the whole data frame, there's going to be some, and we can look at toxic and emotion equals sadness. So I don't see sadness here, but we can see in the entire data frame, there's 522 toxic and negative, and 400 and sadness and toxic. Okay, so moving on, we can do topic modeling. So this basically takes the top topics from each of, I think, 10 different categories. Yeah, 10 different categories, start with 0, go up to 9. Python is 0 based, so this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but they start with 0, so 0 is really 1. So based on topic modeling, we can look at which words come up the most frequent, and we can plot the frequency of those words. So 8% of the time is song. My comes up 3% of the time. This is topic 0, topic 1, yes and bro. You too, love, different topic. 9.5% EST, and then going down to topic 9. You 2020, what is that? 2.0, and Matthew 1.2. Topic 8 has 0.38. Okay, so it's kind of like pretty much the same thing. So LDA is linear discriminant analysis. So we can use account vectorizer and LDA, which is latent Dietrich allocation. This basically helps us classify topic modeling techniques to uncover topics in the text, okay? It treats each document as a mixture of topics. Each topic has a probability distribution over words and uses Bayesian inference, right? So with Bayesian analysis, basically you introduce a few basic concepts and the computer will make an inference or infer a certain outcome. So it's very powerful stuff and very simple and easy to use and to explain to a stakeholder. If you have inputs like small, round, the color is red, and size of a human fist, and fruit, okay, with 5 definitions or defined qualities, you can say that's probably an apple. It's small, round, size of a fist, red, and fruit. That doesn't sound like a strawberry, banana, watermelon, grapefruit, pineapple, coconut. It sounds like an apple, right? So you infer the outcome, right? That's Bayesian inference. And we figure out which topics best explain the collection of documents, right? So it uses a co-occurrence of words. No word has a specific meaning or a context, but looks at how words commingle or occur together. And it might assign different topics if the document contains frequent words that are tied to the topic, even if it's semantically similar to another topic. And for short comments or tweets or YouTube comments, LDA may struggle, while the BERT topic and BERT embeddings often perform better. Okay, so we saw BERT over here. If we go back a little bit, I believe, or does that come up next? Oh, no, here's the BERT model. Okay, so it came up with outputs like this. Truncated comments, are you kidding? It's not just the music. 14 was listening to trap. So that is going to be probably a better output on these short comments like Twitter or YouTube. But we can see what the LDA topic comes out like. Okay, if we go over here, LDA topic is actually 0. So it's just giving us like a numerical representation. Not super helpful. I think the truncated comments, in this case, using the BERT model was more useful. Okay, so let's look at k-means clustering. we can go ahead and set the number of clusters to 5, and we're going to use TF-IDF vectorizer to create all the words into vectors. The computer can understand vectors, very easy, seamless, but it doesn't understand what words are, right? So if we're going to convert every word or sentence or a YouTube comment to be analyzed by a k-means clustering algorithm, we have to vectorize that first. So we can go ahead and do the vectorization and assign a cluster number. So we have 2, 2, 2, 2, 2. Those all go to the same cluster. Then we can look at highlighting the most common comments by sentiment. Okay, so if you have positive and the values are likes, we can say this is a positive sentiment. We can look at the first 5. And if the sentiment is negative, we can look at the last 5. So the first 5 sentiment is going to be appended onto the same data frame at the end over here. Positive, 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 positive. And then we go down here. So sentiment is all negative. Okay, so positive goes with positive and negative goes with negative. So a couple other things we can try is spam detection, reported comments. We can look at comment and then value counts. So, excuse me. So if this is in repeated, I think this is in is really cool. I have a video dedicated to is in. I think that's the least clicked video or least watched video in my whole compendium of 320 videos now. This is the #1 least visited video for some reason. I thought that'd be pretty interesting and pretty useful. I use it a lot, but maybe people don't really get into it. So if this is in repeated greater than 1, we are going to go ahead and count those and say that is assigned to the data frame as repeated. So if we go over here, we can see which were repeated is repeated, false, 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 false. So these are not repeated. Okay, just one comment per user. But if we look at all the value counts and take all the authors that have made comments, we can tell if this is a power user or maybe a bot or maybe a YouTube influencer. So this guy right here, just in this one YouTube video, made 2,703 comments. So I think the video had like 27,000 comments, right? We saw, where was it? That's the first. This is the second one. 27,457. So this is kind of weird, but kind of amazing. This guy made about 10% of the 27,000 comments. 2,700 came from this one user. 2,400 came from this guy. So these are all power users or influencers or something, or maybe robots. And 440 came from this. This is the top 10. Okay. And descending order, if ascending equals false, this is in descending order. So again, the top 10 most frequently counted in terms of comments. So this is one of the last things I'm going to show you, probably the last one. The key phrase extraction with BERT. Remember, BERT is a good text analyzer. It's better than sentiment analysis or what was the other one? Polarity, right? So BERT analysis is just richer, more evolved, more mature way of doing your analysis of YouTube comments or any type of NLP processing. So again, we look at the comment called comment, the column called comment that comes from right here. And we're looking for key phrases. We're using the English word, right? And the BERT model is going to help us with that. So if we go over to the end, we are looking for key phrases. And the key phrase comes up as U2, 42% of the time, concert, 38% of the time, and tour, 28% of the time. So you sum that up, you get 100%. This is music, 51%, mate, 15, and just 14. That sums up to 1.0. Sprizio, I don't know what this is, Spanish, I think. I'll skip that one. Dislikes is 69%, 22% is does, and then trap is about 48% and 46% for dislike. Okay, so just to type some loose ends here. So the role or field is use case. Marketers, content creators improve content based on their reactions. Brand managers monitor reputation or emotional management. Moderators detect toxicity. Researchers analyze political discourse or information, and developers and AI teams train benchmark for benchmark emotion and toxicity models. So this is the type of person that might use this type of analysis: a marketer, content creator, brand manager, moderator, researcher, or developer, or AI team. And this would be the reason why they're doing this type of analysis. So hopefully that was interesting and insightful and invigorating. Hopefully it motivated you or inspired you in some way, maybe. So I'm going to wrap it up here. I try to make all my videos educational and inspirational, a little bit entertaining. I don't know how entertaining they get at the end of the day, but try to do my best with that. Mostly it's educational. That's the purpose here. And I share all the code with you whenever I share the video. I share all the code. I will save it right now. Download this as an HTML file. I will post all the code and the video a little bit later today. You can look for that on the channel. It'll have everything you need. Download the code, download the HTML file. It'll have all the code, and you can copy and paste it, run it in your own Jupyter environment, and play around with it. And of course, get your API key set up. Totally free. It takes no more than 60 seconds, maybe 90 seconds max. You plug the API in here and the video ID in here. If we look for another one, let's look for, I don't really admit this too often, but I kind of like Taylor Swift. So let me look for a Taylor Swift video. And I don't know what this is. Clearly not Taylor Swift. Okay, and then just click on the video. Let me get rid of that. Don't need that thing. Oh, what's this? Blank space, is that the one? Okay, just to prove the point here, anything after the ampersand, you don't need that. And anything after the equal sign is the ID of the video, right? So if you copy and paste that into here, you can do the same analysis on the Taylor Swift video. I'm going to set that back. Okay, because I set this up for YouTube, and that's what I want to save now. So yeah, I just downloaded the HTML file. I'll post that when I post the video later today. Thanks for your time, guys. I appreciate you sticking out to the end. I think you learned a ton if you stayed with me to the end. Let's see, we're at 41 minutes. So this is a little bit of a marathon. I think my longest video was like hour and 10, hour and 15. So we're not breaking any records today, but decent commitment, 41 minutes. Thanks for your time. Appreciate it. I'll post the code in the video later today, and I'll see you in the next one. Goodbye.